represent Kubernetes?
Wow, that's an interesting question. What sport represents Kubernetes? It's an interesting one. I would think. So I guess I'll frame this one as like the Kubernetes project itself, right? So like the actual software components of Kubernetes. So Kubernetes is interesting because like there's a lot of autonomy at a lot of different layers,
Yes.
right? Each individual piece is responsible for its own chunk of the work, and then we have like effectively distributed systems models that allow us to allow all of those pieces to work together as a team, right? As a unit. But there are a lot of things that are responsible for their own bits. And so I think maybe I would probably go with maybe something like baseball.
Thank you everyone for joining it or tuning into the cloudnative.fm podcast. And today we are absolutely excited. I am absolutely excited. One of my dream was to meet one of the wonderful person from the cloud native ecosystem, Duffie Cooley. And I think a lot of the people who are digging into the cloud native ecosystem, they already know the familiar faces behind the so much of the great stuff happening inside the CNCF. And he's one of the forefront of all these awesome tools or all these awesome conferences. You know him pretty well. But if you're absolutely new to the cloud native, today we're exploring a lot of things about the cloud native, Kubernetes, and these kind of stuff. And if you see the logo behind me in the background, and you understand what we are talking about today, we're talking about Cilium. Cilium is a Kubernetes container networking implementation for the Kubernetes. And it's been a very popular, and it's recently been incubated by the CNCF. And all congratulations to all of those Cilium community for this wonderful achievement. And also, if you heard about this noise of eBPF, what that noise is that mandatory, or how to overcome this noise? So we talk about so many things today. Thank you, Duffie Cooley. It's been a pleasure talking to you today on the Cloud Native FM. It's been one of the biggest dream of mine talking to you. I've been a big follower of you on a lot of great things. So introduce yourself to my audience and kick off the session.
Yeah. Well, thank you so much for that incredible welcome, Salim. I really appreciate it. I'm excited to be here. And yeah, like I'm also excited to talk about Cilium, container network implementations, and all kinds of other wonderful things. And it'd be great to dig into the eBPF piece. So
yes, absolutely.
Where would you like?
Absolutely.
Yeah.
So a lot of the stuff I think you're doing for a very long time. I think we can start telling a story about your journey into be the Kubernetes and your journey big into the teaching Kubernetes to other, because you are doing this for a very long time. So tell my audience how you start learning about Kubernetes, and then how you start teaching Kubernetes to other, and that's really effectively. I've learned a lot from you over the years.
Well, I appreciate that. Yeah. So I think I guess a few years ago I was working on a platform that was we were developing sort of a PaaS internally at a very large company, and that PaaS was based on Mesos and our own homegrown scheduler, and we were developing kind of a front end, kind of the way that you would normally think about a PaaS or a platform as a service within a large company. And our goals were to like bring code bases into our shared Git repositories and get them to the place where we can build automation that would allow for the deployment of those things. And at that time, I was really focused on Mesos as a technology, and I realized, we're developing an API that we're kind of like building a lot of the pieces that we need to be able to even define the structure of that PaaS. And I realized also at that time that Kubernetes was coming up, right? So at the time, I think Kubernetes was in the 1.5, 1.4 time frame, somewhere in there. And it wasn't incredibly stable or anything yet, but it was taking off, right? And I could see the structure of that project was starting to take shape. And the structure of that project was definitely solving the problem that I think that anybody trying to develop a PaaS would have, right? It was starting to kind of shape up what that common API would be. It was starting to build like the primitives on which one could actually build a reasonable platform. And I was really excited about that. And so I decided at that time to leave the company that I was working for and go and find a company working in the Kubernetes space. And so I decided to join CoreOS. And CoreOS was absolutely, I mean, because of Tectonic, and it's been funny actually, the last couple of weeks I've been working a little bit on OpenShift, getting Cilium to be a certified operator on the OpenShift stuff, right? And Tectonic, a lot of the work that we were doing in Tectonic is like mapped almost completely into the new OpenShift 4 series stuff. It's like, it's wild seeing all of that come back. But to that point, at CoreOS, I was a solutions architect, and a part of that solutions architect work was to do some developer relationship stuff, right? So basically get out there and share publicly how this stuff works and why it's exciting, and do talks and go to meetups and do all of that stuff. And I realized, you know what, I like that. I like doing it. I like watching the light come on in people's eyes, like when I explain a thing. I like being able to break down a complex thought or project in a way that is approachable, and that people don't feel like they're, looking at this myriad of thing and going, how do I even start? Like I want to help people start. I want to help people figure out how to come about that, and that's always been true of me. But at CoreOS, that really kind of lit my fire. I was like, this is really, I'm really digging this, and I really enjoy like working with teams, and I really enjoy doing that, public facing, customer facing kind of work. And so I did that a bit at CoreOS. I wasn't really doing any vlogging yet, but then I was doing a lot of internal presentations and doing a lot of education of my team and education of teams that I was working with that were customer teams that were adopting Tectonic, et cetera. And then from there, I moved into, when CoreOS was acquired by Red Hat, I left CoreOS and joined Heptio. And Joe Bita and Chris Nova had already started TGI K8s. And I thought, what an incredible platform this is, right? Like, one of the things I really liked about TGI, I still like it about TGI K8s, is that it is a platform on which what you're presenting is about the Kubernetes, the space, right? It's about Kubernetes and about the space, the cloud native ecosystem. It's not about a particular product, right? I'm not trying to, when you're watching a TGIK session, I could be talking about how to break down the code base in the controller manager, right? Like, and there was no requirement within that structure that I had to be talking about, VMware products or about Heptio products. The idea was to just maintain kind of a focal point where we could bring what was happening in the ecosystem or some of these complex projects, or evaluate different things just in the ecosystem and get out there and talk about it. And I thought that was, I still think that that's an incredible opportunity to go, like be a part of that. And so I ran that for some time, and really enjoyed it. And then I decided to, explore other options. I was kind of at the end of my time at VMware, and I decided to look around a little bit more. I ended up going back to Apple for a little while, and then I had an incredible opportunity to work with some people that I worked with before at Nicira many years ago, and I decided to join Isovalent as field CTO, and now I'm doing very similar work, where I'm doing solutions architecture, helping people figure out how to use the product, helping people understand what this whole eBPF and Cilium thing is all about, and also like doing more video blogging and like that kind of stuff, and helping people like dig into the details and stuff.
Yes, absolutely, absolutely. When I saw you first time you joined the Cilium team, it really was a wonderful experience, wonderful news for me actually, because I've been watching and wondering if to find a member from the Cilium so they can talk about some of the exciting thing happening in there. But I think that I've talked to the TM, Thomas Croft, and I think Liz. They are most busy person. We haven't good. I haven't tried to talk with him. So when I joined, I think there is one of member is wonderful for me, so I can talk about Cilium and all the things happening there, because they've done a wonderful job on the networking side of it, making easier and easier and easier as well. And your journey has been wonderful. Like you starting at different companies like Heptio and the VMware is a kind of the backup solution in the Kubernetes, like how to back up in the Kubernetes APIs. Wonderful project. I
Yeah.
think people who are listening to us go explore that project as well. If you're backing up your Kubernetes cluster as well, and then you transition to the completely new space like container networking space. So how this journey? Tell us about this journey because people are in the Kubernetes in this part in this year of time like 2021, 2022. They're working with some specific domains, but very few people like you who are learning about the whole ecosystem. So what your transition from the backup in the Heptio, the CoreOS also, they have a wonderful team. Like I think Kelsey, Joe, there are wonderful people involved in the CoreOS team. And a lot of the innovation happening today is behind the CoreOS team was then. So how you
It's true.
transition
Yeah.
from the roles to roles from backup Kubernetes backup solution. Now you're working with the Cilium CNI. So how you're transitioning? You enjoy that transitioning, and people who are listening to us, share your thoughts around if they want to transition to different domains inside the Kubernetes ecosystem.
Yeah. I think, so this is, I've, spent some time talking to a few friends about this and like trying to figure out how to conceptualize this. And I think what it comes down to some degree is, developing like in yourself a culture of experimentation, of learning, right? Like you want to engage in your career, like whatever your path is, you want to engage in a way that allows you to continue your learning. Like it's the most important part, right, in my mind. And the reason I say that is so important is that, like, I'm on a path that has taken me through a variety of different systems. To your point, right? I helped reinvent the network at Nicira. I helped build network virtualization a number of years ago. I worked on OpenStack, one of the first big distributed systems that I worked on, and then moved from there into like Mesos and all of these things. And I think that really it's about the fact that like I am always curious. I always want to know more about. I want to know more about what's happening with a different project, and I let that kind of drive me into the details about how the different pieces and parts work, and like getting to a place, whether that means like leveraging a project like kind.sig.k8s.io, like, a project like that to really be able to kind of tear the project apart and understand how all of the pieces work and how they communicate, and being able to really kind of like dig into the detail and model all of that in my head. Like, I think, being in a situation where you can actually like play with all of the parts and really understand how they work is a huge boon. And every project that I've learned, whether it was OpenStack or Mesos or Kubernetes or CNI, like the one that I'm working with now on Cilium and eBPF, like every one of those projects, I have an environment on my laptop that I can use, whether that be, like a set of VMs that I bring up with Vagrant, whether that be Kind, the Kubernetes and Docker project, whether that is, any of the other tooling that I've worked with. I'm always like trying to figure out how I can explore that stuff locally without having to like, maybe invest in like cloud resources and those sorts of things. And I can tell you that Kubernetes itself is probably the easiest project to explore in that way, right? Because then you're sometimes we refer to this as cloud privilege, right? If you're working for a company that's willing to foot the bill for you to explore all of this stuff in Amazon or Google or Microsoft, that's great, but it shouldn't be a requirement for you to dig into this ecosystem and for you to start like exploring this stuff and learning about it, right? You should be able to do that with just your laptop. A laptop is a high enough cost. You know what I mean? Like,
Yes,
and what you build, yeah. I was going to say, what you build over exploring all of these things, the big benefit to you, which I think a lot of people don't realize initially, is that you start building an intuition about these systems. You start building in your mind the framework that you will use to understand how a system works. And that intuition is the real value. That, like, if I'm looking at one particular thing that has enabled me to move between different domains, it's that intuition that I've built over time in studying these different systems.
Yes, absolutely. I think right now, as we need these kind of personalities in the community as well. So there are people at different domains. They have understanding of, let's say, the container runtime interfaces in the different orchestration like Mesos or Nomad and Kubernetes. Also, there are people who are very wonderful knowledge around the appealing knowledge around Kubernetes containers like Docker, Podman, Builder, all of the stuff happening there. So let's say if I want to learn about, let's say, some new things, it might be difficult for me to connect with other people. Might be they busy or they are having work on their different projects and not able to meet me. So we need like person like you in the community everywhere, like who people can tell us the whole scenario, hold the pictorial overview of this kind of stuff. And a lot of the stuff you mentioning on the your live streaming on the either on the Echo that the Cilium hosting, also on the TGKI K8s. People who listen everything, I think everyone who watch your show, they learn a ton of new cool stuff because you have a wonderful background of different domains and working on different part of it. So I think hats off for your knowledge gain over the year, and a part of that you are sharing your knowledge continuously with people. I think that's really appreciated from my side as well. So we talk about your whole
Yeah, I think
journey.
that I was going to say, I think that people, I don't consider myself to be an expert in Kubernetes. I certainly know a lot about it, but I wouldn't consider myself to be an expert. And I think that what's interesting, I mean, to your point, like how we level everybody up, how we do this stuff, right? Like, first, there's a whole group of us that are called cloud native ambassadors, right? So if you're a CNCF ambassador, it's part of the task is to help level everyone up in this ecosystem. And I have the honor of working with a number of really incredible ambassadors in this space. But second, getting back to the expert point, I think that the way that I evaluate whether somebody is an expert is by the number of people that they have helped versus the amount of information that they have gained, right? Like, I know a lot about different things, but I don't think that that's the value that I bring to the world, knowing stuff. I think the value that I bring to the world is sharing that knowledge, leveling everyone up, right? These are the perspectives that I think are useful. I want to share them with you. You know what I mean? Like, and I think I do wish that was more of a drive for more people. I want everybody to like share their knowledge because like that's how we all win, like.
Yes, absolutely, absolutely. I think you are listening to us in the podcast. I think the greatest way to test your knowledge is to share your knowledge because when you share your knowledge,
Oh, absolutely. Yeah.
when you share your knowledge with other, might be you are losing some points on it, and somebody adds on top of your points, and that's paved the way for innovation for all of us, and it's paved the way for success for all of us as well. So we talk about this kind of stuff. So tell me, like a lot of the open source project right now is happening under the umbrella of the CNCF. But I ask all these who people join me during the podcast time, how we look at the app open source, because the open source model is like if I am an open source person, I have a project there. People find it really difficult to scale their business from the open source project. But the company like Google or Microsoft or AWS, if they wanna make their project open source, this gives the value for out of their business as well, can initiate the booster. So tell us about the open source model, because what I've seen from over the years, that company built out some open source model like Cilium is open source, everybody can use it as they want it. There are some other projects around the CNCF like container runtime interfaces, storage, service mesh. They're all open source, and people make the business out of it, like provide the SaaS platform on top of their open source offering. That's what I learned over the year, that how the open source model operate. But your thoughts is absolutely vital for all of us who are listening to this podcast. What do you think the open source, what it is, and how you can build a sustainable model out of the open source projects?
Yeah, I don't think that there's a perfect answer to this question yet, honestly. I think that we're all still learning about the long-term effects of this. Um, I am a huge fan and advocate of open source, and the reason for that is like it goes back to that same point, right? Like, with open source, we have more eyes, we have more hands, we have more capability of moving together, right? Like I don't remember exactly where I heard this quote the first time, but they said that if you want to go fast, go alone. If you want to go far, go together, right? And I think open source is kind of a perfect capture of that idea, right? Like if you want to, like the most successful projects that I've seen, or the most lasting projects that I've seen, have always been open source. I was recently up at the 30th anniversary of the Linux Foundation, and it was really incredible to see, like, the celebration there. All the people that were present, and just the incredible effect that Linux as an open source project has had on the world, right? Like just so I'm a huge fan of open source and that tech and that model. And I really do feel like as companies start adopting products, it becomes a thing where that becomes a prerequisite for those projects that they're going to adopt, right? Like I don't think that we could remotely succeed as Cilium as a project if it weren't open source. I don't think that today in this ecosystem that like having a closed source CNI would be remotely successful, right? Like we like it's a prerequisite not only for the people adopting this technology, but also for the people presenting this technology that we have that open source component to what we're doing.
Yes,
Now, building a sustainable model is a different gig, right? Like building a sustainable model means that we have to figure out how do we provide a value that people want to pay for, right? How do we provide a value in this product that that is something that gets past the point where people are actually interested in paying money for it. And I've seen a number of different models over the years. Like some of those models have been like it's a support model, right, where you pay for support, and that engagement is enough to keep the company alive. But is that going to be enough to build a sustainable model over time, right? I've also seen models where people take the product that they've open sourced and then they build effectively kind of a competing product for that same application set, and they sell that competing product as the enterprise offering, and they still give away the open source model. And the challenge is that, like, in reality, these are the same product, and they're kind of competing against themselves. In Cilium, I don't think that we have that particular problem. I think it's important that we've learned a lot from like what's happened over time with different projects. When you think about the difference between Cilium and Cilium Enterprise, like in Cilium Enterprise, you're still deploying open source Cilium. That's the base framework on which we do everything. And that's important for a couple of different reasons. That's important because that means that contributions from Isovalent against the Cilium code base are continuing to move Cilium as an open source project forward. We continue to accept contributions from a variety of different companies. There's like 300 something contributors across, like, I can't remember how many companies it is right now, but like it's a huge contribution base to the open source project that moves that project forward. And when we start developing what the enterprise product is, we're developing on top of what we've learned in eBPF. We're developing other features that are interesting in the enterprise ecosystem. Things like being able to integrate all of the network event data that we capture, or process event data that we capture with your SIM, helping you build models for understanding when interesting attacks or novel attacks inside of these to allow for like better auditing of security processes within your Kubernetes clusters. Being able to and support is also a part of it, but it's not the only piece of it that makes Cilium Enterprise worth more, valuable in a monetary way to enterprises that are out there. Right? So it's interesting stuff. But yeah, I think that Isovalent has the right model on it. It's basically, instead of trying to compete against the open source product that we also developed, we're coming together. We're using that as a base for what we're building in the enterprise value side of things. Yes. And I think that gives us a pretty good sustainable model.
Yes, absolutely. Thank you very much for elaborating all this. So it's I gain more knowledge during the conversation you have around the open source modeling. So now before we jump into the Cilium, so tell us about the container networking ecosystem for our audience who are listening to us, and drive the conversation so we can better understand the eBPF model, eBPF noise that's happening along the way, because I think most of the people might not familiar with the eBPF like we all as we are, because we are the consistent in the ecosystem. But many of the vessels, they are working on the networking side in the old fashion, like they're using the IP tables and
Oh yeah,
some legacy code bases. So tell us, my
yeah.
audience, what the networking ecosystem was and what are the potential drawbacks in it, and how eBPF improve those limitations that we already have in the container networking interface.
Sure. Yeah, I mean, I've worked with a bunch of different CNIs, both at Heptio and at CoreOS, because I think CNI implementations were changing over time. I think the first one I ever saw was Flannel, and I thought that was the most elegant CNI that could be. Um, but just as a high level overview of like what a CNI does, a CNI is responsible, that container network interface. It's responsible for ensuring that all of the pods that you deploy as part of your deployments or daemon sets or replica sets or what have you inside of Kubernetes, all of those pods can intercommunicate. And the CNI is basically responsible for that bit of it. And so if we go just a little bit deeper, what happens is when you make a deployment and that deployment results in a set of pods that are going to be deployed onto all of your kubelets, when that kubelet starts up a pod, part of the work is making sure that that pod has a network interface, right? So that it can actually reach out to the outside world or to other pods. And in that process, like the way that works, when the pod gets initiated, something has to basically generate what's called a VETH pair, or a virtual network interface pair, that looks kind of like a pipe. And it takes one half of that pair and puts it inside of the pod's network namespace, takes the other half of that VETH pair and puts it in the host's network namespace. And now we have a way to get packets back and forth between the pod's network and the host's network. And then we also manipulate things like IP tables and routing table rules. We might turn on some form of encapsulation, whether it be VXLAN or IPsec or something like that, that would allow for us to ensure that when this pod tries to communicate with another pod on another host, that we have some way of getting that pod traffic back and forth between hosts. And this is all part of the implementation of a CNI. Now, what's interesting about the eBPF side is that eBPF is basically a way to build programs that can manipulate or change the way, or even control the way that system calls happen up at the kernel layer. We think about it that way. And also just like manipulate arbitrary data that's happening back and forth between those system calls. Like when so to kind of put it in simple terms, where most CNIs, they actually bring up a pod, they do that VETH pairing, they manipulate some IP tables and some routing table rules to allow for communication. What we do at Cilium is a little bit different. What happens is the same on the VETH pair side. We're still responsible for ensuring that pod traffic can move back and forth between nodes. We still set up IPsec or WireGuard or VXLAN or what have you between all of those nodes and all of that stuff. But what's different is instead of catching traffic as it egresses that VETH pair, with eBPF, when we see the connect call, that TCP connect call at the system call layer, like at the kernel layer, because basically your application, when you type curl google.com or whatever, or even a different pod service IP or anything like that, you're making a system call to the Linux kernel saying, open this TCP call to this destination, right? And when that happens, we, using eBPF, can write a program that says, okay, well, that was a system call coming from this process. I understand that process to have this identity, right? And this identity is unique to all of the pods in that particular replica set, or some union of labels. So now I have some unique identity that I can actually work with. And now I can actually, using eBPF, do all of the things that a lot of CNIs do with things like kubeproxy. I can do a lot of the things that I can do some really intelligent decision-making about what happens with that connect call. I can do a thing, for example, like in most cases, if two pods were going to communicate back and forth, or a pod were going to communicate with a service IP, right? That pod maybe makes a curl to a service IP inside of Kubernetes, and kubeproxy will try and determine a healthy endpoint behind a service and use IP tables to manipulate the destination IP address of that connection call to one of the healthy endpoint IP addresses on the back end of that service. and then the connection will connect, and it will route through your routing table, and away it will go. Also, if there are like network policy or anything else like that, that's another set of tables that the packet will have to go through and determine whether it's allowed to egress or allowed to ingress into that service IP. With eBPF, we can do all of that just right there at the kernel layer. And that means that as dynamic things change, as any of this, I mean, as pods come and go and service IP addresses come and go, like we can actually very dynamically, very quickly make a change to just one simple BPF map and see that change immediately take effect across a very large scale thing. Whereas like if you're leveraging the IP table side of things, there's no atomicity in IP tables. When a pod goes away or comes in or any of that stuff that happens, if you make one change, one line change in IP tables, the entire IP tables rule set has to be reloaded in the kernel space. And as you grow the number of endpoints that IP tables has to know about, as you grow the number of services that IP tables needs to know about, to be able to satisfy Q proxy rules across a very large cluster or even a reasonably sized cluster, then you end up in this convergence problem, because it takes a while for IP tables to completely evaluate everything and start enforcing the way that traffic needs to move according to IP tables. And that also creates problems. It's like it's a cyclical thing, right? Because as you create more churn, as it takes longer to converge, you end up in kind of a worse and worse state over time. This changes that model. Instead of thinking about like one effectively monolithic thing that is IP tables that has to think about all of the connection state or tracking and everything that has to happen between all of the pods inside of your Kubernetes cluster, what if we were just to change that model such that we could actually do that at the application layer? When your TCP connect call happened, we could actually understand rich context about what happened with that connection, and we can also make very intelligent decisions about what happens right there at eBPF, right? And we can dynamically change the information that eBPF program is consuming. Like if endpoints change, we can update the map. We can do all of those things much more dynamically for every connection in the cluster. It was probably a little bit too much, but I hope that was helpful.
No, it's a wonderful. I think people listening here, they understand the power of eBPF. But I think that's a wonderful knowledge I gained during the conversation, how the container network interface work under the hood. I see it as a container network interface and the IP table and the eBPF. Like, let's say we would draw the analogy here of the stack. You can know in the stack you can just pop the topmost layer of the element. But let's say you wanna need the fourth layer, third element, like be the index in the element that is living the index number 2. For some reason you need that. You don't want to go the swap on the topmost layer and then go to the 3. It might be the slowest possible scenario, but the faster you can directly route the traffic to the 2 second elements of the stack and then pop that up. So people can draw the analogy here, the stack work as it is, but let's assume for the particular scenario we can need a element in number 2 and we can directly route that as well. So I think the Linux kernel and the eBPF, they are very intelligent. During the syscall model that you understand, that you draw, you can manipulate many of the things. So before the kernel, because we are recompiling and manipulating the circle during the syscall time, like during the connection request.
Exactly.
So it's actually wrap up the whole discussion. It's changed the mindset of the people, how we think about the networking under the hood, because I think the eBPF is an extended Berkeley packet filtering and BPF is for the networking layer. So people then think about it's not just for networking. You can do all of the most scenario with the eBPF as well. So like you draw the mention on the IP tables. It's really complicated. I see that Kubernetes written out some blog posts. It's not going to scale well when you have thousands of pod.
I mean, if you think about it, it was never designed for that, right? I mean, like it's kind of wild when we think about this container technology over time. You know, like as we think about Kubernetes and Docker and all of the other different technologies that have come along, like these are repackaging of tools. This is a lot of this is repackaging of tools that have come before and trying to make, kind of scalable models for how to handle better isolation for processes and those sorts of things. And Docker is did an incredible job of making that more approachable. But at the end, when you look at what's happened here, they basically have, one of the things that Docker has done is figured out a way to take like existing primitives and make them more consumable for things like containers, right? A lot of the technology that containers represent, those namespace isolation pieces, although they have definitely advanced over time, right? Initially, like a lot of those primitives existed. They just were very hard to kind of put together into a way that could be consumable by folks, right? LXC project was one of them that tried to do a similar thing. But to that point, a lot of those primitives were built in a time when computers would run like a program. It would run a web server. And so the set of assumptions that existed at that time were very different, materially different than the set of assumptions that exist when you think about a container, a host being a container host, right? Where you're trying to rely on the Linux kernel to be able to provide better isolation between all of these processes, where all of these different processes have some things that are namespaced and some things that are not. They're all relying on the same Linux kernel, right? And so it becomes a very different challenge. I think where eBPF really shines, to your point, is that it brings new thinking to that problem. And we've seen that over time. Like there's definitely an effort to try and move iptables itself into an eBPF mode, right? Like being able to leverage a different model for iptables. It's an ongoing effort within the Linux kernel to be able to achieve that. Even within Cilium, we're actually, the way that the Cilium project is leveraging BPF, we've seen over the period of the time that the company's been alive, there's been an incredible effort in two different directions, which has been interesting. One set of effort is around, building and maintaining Cilium as an open source project and getting it out there and getting it adopted and getting people interested in what's happening with it. And that effort has gone incredibly well. Like you said, it's kind of the default CNI in a lot of different environments these days. But the other set of efforts that has also been very important is the kernel contributions that a lot of the folks at Isovalent have done to extend what's possible with BPF, adding more BPF helpers, which are basically functions that allow you to understand a little bit more context about what particular processes are doing, either at a process level, like what files they're opening, what things are happening, or even at a network level, like what network namespace did this packet originate from, right? Different tools extending the eBPF space inside of the Linux kernel to be able to make it so that not only can Cilium make better use of eBPF as a technology in the Linux kernel, but also that anyone leveraging the Linux kernel can get more capability out of eBPF inside of the Linux kernel. And so those two efforts together, I think, both really both an incredible amount of effort that the Isovalent team and the Cilium community and the eBPF community have spent a lot of time on in the last few years. It's just really neat to see it all come together into such an incredible project.
Yes, absolutely. Before we jump to the Cilium incubation in the CNCF side, as we draw a couple of points on this topic, as we know, the question was on topic of this conversation, like as you mentioned that IP table is never designed to think about this problem of 20,000 pod needs IP. It's not designed because the problem they try to solve had in the virtualization, but the container network, container ecosystem is a different from the virtualization world. So what do you think at this moment of time, in a very shortest amount of time, in the Kubernetes is 7-year-old and then it's donated to the CNCF. I think CNCF has 6-year-old, Kubernetes 7-year-old, with a very small amount of time. How do people realize these problems and solve these problems in a very fast, very generic and scalable way? We haven't think about these fastness, scalability of these problem to solution in the past in the virtualization wave. But in the container wave, we see very small amount of time. People put together a wonderful effort and they build out a scalable solutions. And when they find the problem, they come up with a wonderful solution like the eBPF solution they came up. So what do you think? What missing in the past when people are moving to this, providing the solution, and what's make this place or this ecosystem wonderful. So everybody is the fastness, reliability, scalability to these solution. What do you think? What is the uh, cornerstone of this whole story?
What are you asking? Like, what are some of the other pieces that are missing, or are you asking like what is the where are we at with eBPF in relation to solving this overall problem?
Yes, the question is that we have virtualization world. We have seen a amount of problems in the virtualization world, but it came very late, like 10
Sure.
years. People
Well,
need to understand. But in the container world, we see even in a 6 5 month, we think about how complex it is. Then we see the solution is already available in the CNCF landscape. So I was talking about the
yeah,
how fastness the community matures and how fast the solution mature. What is the uh, who what is the power behind this fastness and maturity of these open source solutions?
I got you. Yeah, I think there are definitely a few different parts to it, which I think a part of it is that like I think to some degree we're people say that we're in an age of distributed systems. And I think this is an interesting point, and I think it brings with it uh, a lot of that intuition that I was referring to before, right? When we think about the way that systems work in general, or have worked in general over time, um, we're thinking differently about the way that we deploy and model applications um, that represent very large web apps like the Googles and the Facebooks and the Yahoo and those sorts of things out there today, right? For the longest time, we were using things like Ansible and Puppet and Chef and those sorts of things, and being able to effectively distribute like some subset of our applications on some subset of nodes in a very large data center, or a group of very large data centers across the country or across the world. And that was kind of the model that we were in for a very long time. Then we introduced this whole cloud idea, right? Like Amazon came along, we had Google come along, we had Azure is out there. There's a variety of different cloud environments now where you can basically pay hourly for virtual machines. I mean, VMware was another one. I would say even VMware was like probably one of the first to really kind of succeed at that model, right? Because they kind of introduced this idea of virtualization, this idea that like maybe instead of thinking about these servers as like individual places where you can put applications, maybe we should think about these servers as virtualization hosts. And now you can create multiple of these virtual VMs on top of things. One of the promises of virtualization was that we would be able to have like, we would be able to create VMs and destroy VMs and like, not have to keep them around forever. We could actually like, improve the security model of things by having some subset of our applications deployed within VMs, and then we would be able to throw those VMs away. They would be short-lived, and we would that never really materialized in the virtualization space, right? When I look at OpenStack, the way people are consuming OpenStack, the way people are consuming VMware, that promise of short-lived VMs was never a thing. It never really took off, right? Instead, what we saw was just more long-lived VMs running on all of these hosts and all of the problems associated with it, which I think is your point, right? Like that we never really kind of reached a point where we actually realized the promise of that. With containerization, it's a different gig, and I think it's fundamentally different because a container is a Linux process. It lives and dies with that construct of a container. When that process exits, that container is gone. You're not going to get the container back. Like you can't restart the VM. You know what I mean? Like this is not a long-lived process by definition. Right? When you make a change to a deployment, when you make a change to a replica set, even within Mesos, right? Any of these container technologies were kind of defined wherein like we could say that this process with this isolation model is going to be, it's only going to live as long as the deployment of that process lives. And if something happens to the process when it exits or, seg faults or anything else like that, that process and its entire container and its entire state is gone now, and you will have to create a new one. And so I do think that finally, with container technologies and stuff, we're actually starting to realize that promise of short-lived processes. We're able to start to realize the benefits of the security model in saying, you know what, the attack surface of this process is the attack surface that I need to secure, rather than the attack surface of the VM, that long-lived VM being the thing I have to secure. I can actually start focusing on the attack surface of that process, right? And that, I think, is an improvement both in the security model and also in basically in a lot of the ways that that all of this stuff is consumed over time. How these things get to maturity so quickly, how these things become so mature, so mature and so quickly. I think, again, it comes down to an early decision by like Joe Beda and Craig McLuckie and those folks, where they decided, you know what, this needs to be an open source project, right? We see Docker happening. We see a need for an orchestration model that, like, you know, provides that set of primitives that are needed to effectively develop a PaaS. We see all of that stuff happening, and we know that. And they made a really incredible decision at the time to open source Kubernetes and to start, you know, to start the CNCF and to do a lot of that work. When I try and understand like the maturity of all of this, like how this happened all so quickly, if it weren't for that open source community, if it weren't for those decisions, those early decisions where they said, you know what, we learned a lot from the previous experiments in this space, and without that community, we have nothing. Right? Like without that community of people, without all of the eyes on the problem, we're never going to get to the place where we can together solve a larger problem like container orchestration, like being able to drive the adoption of container orchestration in this ecosystem. And so that, I think, leads to the maturity, including, I mean, the other pieces of it, of course, like are all the adoption, right? Like getting more and more implementations out there for people to use Kubernetes, for people to adopt it, like seeing different companies like OpenShift or Red Hat and OpenShift and like, you know, Kinvolk and CoreOS and, you know, any number of different cloud implementations that are adopting Kubernetes, EKS, AKS, all of those different things, basically getting Kubernetes to be so out there so much that like everyone is using it, and they know that if they have a problem, there's a community to help them understand if their problem is unique or if that problem has already been solved in some future version, right? There's it's an incredible situation, you know. Like, I mean, a parallel to this is like if you think about like router code, right? Like Cisco's and Juniper's and all of the other things. This is mostly closed source code, and when you have a problem that is related to the way that, like, you know, iOS or JunoOS or what have you works, like you might be able to find an article of somebody else having a similar problem, but like you have to, you know, wait for the developers on the inside of those companies to be able to find and isolate your issue and resolve it and maybe release a software version that will fix it. Right? Whereas in Kubernetes, you say, okay, this is my problem, and you'll find any number of people in the Kubernetes Slack or in what have you that says, oh yeah, that problem is related to the controller manager. This is the issue that captures that problem. Is this your problem? Yes, no, right? If it is your problem, great, right? Because that captures the problem, and you can contribute code to fix that problem today. Or you can, you know, basically provide information and maybe help people validate that when that change, when the change that resolves that problem works, that it works for you. Right? That helps you close the loop, right? People who are contributing code to solve these problems inside of the Kubernetes ecosystem are able to see immediately that the change they made does actually work inside of the problems where this problem exists, right? And it's like that loop, that ability to contribute to something so incredible as Kubernetes, and being able to understand that when you make that change actually materially helps, you know, all of the people who are out there adopting this product or trying to make use of it in production environments. Yes. That we can do all of that out loud is amazing to me, you know, like, and that drives the maturity.
Yes, absolutely. I think that the point we all gave is, and during that discussion, when starting the conversation, is that sharing the knowledge. And the open source is all about sharing the knowledge. And with the there are so many minds involved in it. So we have a collective knowledge and a collaborative knowledge of everyone can
absolutely
commit to this repository, and everybody thinking about the same problem in 3 or 4 different ways. And then you can union or intersection the collaborative knowledge and then put together in the open source. I think that's give us a wonderful project like Kubernetes, and the Joe Bait and the team who make that is open source. I think they are really appreciated for making a huge assumption, because on that there are some things in mind, like, but they open source it. And right now, if you think about some problem, like when I start learning about Kubernetes, I see the cluster, how to navigate between different cluster in 2019, and I see somebody wrote a wonderful extension kubectx to
Yep. Yeah, I'm at.
okay.
Yep.
Yes, absolutely. So the point I try to give is, when you think about the problem, it's already solved in the Kubernetes ecosystem. That is a power of open source. Absolutely, that's the whole
Yeah.
conversation. That is actually a power of open source. People think about it, contribute to the open source, and everybody can use it and make their life innovations make the fastest way as well. So before
And we're oh, sorry. I was going to say, and we're building that same community, like, in the eBPF ecosystem. If you go to eBPF.io, you'll find ways to come and be a part of that community. And if you go to Cilium.io, you're going to see we just revamped our webpage to have a bunch of new information, including links to like a weekly install fest or a weekly AMA with our with one of us, with one of the folks behind the Cilium project, like myself or Liz or Liz Rice or Thomas Graff, or you can come and ask us questions at any of those things. You basically just go to Cilium.io, you'll see a link to our weekly AMA or our weekly install fest, and just come participate and be a part of it.
Yes, absolutely. I think I absolutely own these words that Duffie has stole, because eBPF is moving the same way as a Kubernetes, open source for
Yeah.
everyone, and people
Yeah.
every day contributing new solution into it, and it's fast moving, and everybody talking
Mhm.
about it. So I think all the links is available if you want to contribute or get started with eBPF, and I think eBPF and Cilium Office Org is a wonderful place for you to talk about these eBPF things, as we call is echo for the short. So
Yeah, definitely.
absolutely. So before I ask the incubation part of it, so one final question before when we start the whole is, you spend time with the VMware, a lot of the VM like Heptio. So people think about it, the VM, all the first company who gave us virtualization, then the containerization wave come up. People think they're not as successful as the virtualization wave, or they build out some solution but it's not getting hit or popular. So what you think is missing from the VMware side? What you think? I think they have a wonderful company, wonderful project still in the area of Kubernetes. Like they build out the ingress control, and also they build out some solution, the Heptio. They have the VMware Tanzu Community Edition, the service meshes, all that kind. But still, people still think they have not as popular as with the virtualization wave. So what's your points on that?
I think when I was at VMware, I was actually part of the Heptio acquisition, and we were doing a lot of work on kind of changing the model, helping VMware realize the relevancy of container orchestration systems in today's markets, right? So like, I don't think I've ever seen. I have to really think. I have to back up a little bit. I'm not sure how much of the previous answer was captured, but I'm going to start again from the top here. Okay, so it's interesting, and I think we have to be careful when we think about whether VMware has ever been like, it is in fact declining, because I do still see a lot of adoption of VMware technologies over time. And as a technology company, it's like one of the companies that I've been at twice now. I was there at VMware through the acquisition of Nicira, and also through the acquisition of Heptio. And I have to say that like VMware as a company is actually still a super solid technology company. As an engineer or as a technologist, it's a pretty reasonable place to work. Part of the effort of coming in as Heptio was actually in helping helping VMware understand, like I said, the relevancy of container orchestration systems in today's market. And one of the amazing things was watching folks like Craig McLuckie and Joe Bita and a lot of my coworkers on the field engineering team kind of bring a lot of Kubernetes knowledge to what the efforts were there at VMware. And so that kind of formed the project, the Tanzu project, right? The Tanzu project at VMware has really taken off. And there are a couple, and they've really moved open source technologies like Cluster API forward. Like they still have a lot of the major contributors to SIG cluster lifecycle, and they're really, and VMware is really focused on bringing the ability to create task-built clusters and to manage all of those clusters in a way, in a software automated way forward, right? Whether that means contributing to SIG cluster lifecycle's cluster API project, whether that means contributing to kubeadm, which is like one of the subcomponents of the SIG cluster lifecycle project, whether that means developing and making use of things like Tanzu mission control, the ability to understand like all of the clusters that you deployed, and some rational tools for understanding like how all of those clusters are configured in a more consistent way. Like all of that effort, I think, has really helped VMware find relevance in this ecosystem. They've recently announced the Tanzu Community Edition, and I actually talked about that at VMworld this year. Right, the Tanzu Community Edition is really, I think, a great thing because it, again, kind of adopts that same model that you were talking about, right? You have an open source project that is the Tanzu Community Edition. Anybody can contribute to it, right? And from that open source project, that open source project informs instability and also like the capabilities and all of the different projects that people are going to interact with on the Tanzu Community Edition inform what the Enterprise Edition looks like. Right. And so I think that model of like being able to provide a way for people to extend and adopt and make use of the Tanzu Community Edition version of all of this, and then having the Community Edition inform what's in the Enterprise Edition is actually incredible. It gives you the ability to, especially as a network vendor, right? Like as a CNI vendor, I can actually contribute Cilium as a CNI to the Community Edition, and as it reaches maturity there, they can promote that to the Enterprise Edition. I mean, that's an incredible thing.
Yes, absolutely. Thank you very much for elaborating, because this is a question people ask every day about because they are the inventor of a wonderful virtualization technology. I think for the containers and the virtualization, they work side by side. They haven't taken out the market of anyone, because if you use container, I think 90% of the folks still using virtualization in some way, like Windows.
That's true. Yeah, probably more than 90. Yeah.
Yes, absolutely, absolutely. Like WSL is still using the virtualization and other kind of stuff. The virtualization and container, I think, moving forward, work alongside each other and never taking, because at the end of the day, Docker itself using the virtualization technology to spun up the container for ourselves. So
I completely agreed.
Yes, I think it's going to be side by side. So before I final question, before I let you go, talk us about first the congratulations on the Cilium Incubation to the CNCF. So I think absolutely. So talk us about why it is so important and what it means for the incubated project in the CNCF, because incubated, then we have another stage, then we have a graduated project. So tell me about, I'm really confused about this model of incubation and then graduating. What the step involved and what incubation means for the Cilium community?
Yeah, so a CNCF project, when donating a project to the CNCF, you have a variety of different levels of that project. Whether the first is like levels. Let me look this up because I always forget what the actual. The first is, I think, sandbox, right, where you basically are donating a project that maybe hasn't seen like a lot of adoption yet, but at the same time, what you want to do is kind of like use the CNCF project to drive more of that adoption. You want to attract it. You want to make it so that it's open source, that a lot of these that the code itself is easy to contribute to, and leverage a foundation like the CNCF to basically enable that consumption, right? So the first level of this is sandbox, and that means, again, like there may not be adoption. What we already know about the Cilium project, as you said already, is that there is a ton of adoption, right? Like we see EKS Anywhere using it as a base CNI. In GKE, it's the foundation of Data Plane V2, right? It is the de facto CNI in the ecosystem today, and it's really taking off in a lot of even in private projects. And so we already have the adoption. We already have contributions from 100 companies or something like that. It's a ton of 300 different developers working on the project. not all of them, obviously, that work at Cilium, because Cilium's only about 50 people right now, or Isovalent's only about 50 people right now. And so that's an incredible thing. And that means that when we contribute the Cilium project to CNCF, we're coming in as an incubating project because we've already seen a lot of that adoption. There's this chasm that they describe in the CNCF documentation when they describe the different levels of a CNCF project. That chasm is between incubating and graduated, and the chasm represents kind of like that early majority of adopters of adoption, people making use of it in their Kubernetes clusters in this particular case, right? And I think we're in a good position to move through that chasm pretty quickly because, again, it's the de facto CNI out there. But yeah, I mean, I think I wouldn't be surprised if we weren't, terribly far away from a graduated project. I don't know how long we'll be in incubating, but we're using it as a mechanism to ensure that people understand this is an open source project, that contributions are welcome, that we're very focused on being a very good open source steward of that project and moving it forward as even under the CNCF project, not just underneath Isovalent, right? Like, this is everybody's best CNI moving forward, and we should make it available to everyone, whether that means contribution or just adoption.
Yes, absolutely. I think we have a wonderful speakers and public speakers and the technologists around the eBPF and Cilium side. That's a great news for everyone who are adopting Cilium right now. We have so many people who every day talk about eBPF and Cilium. So I think there's a very less time, but hopefully in the next year, when we start the next year, hopefully in the moving forward, you understand that the Cilium is finally the graduated project in the CNCF, but it's moving in a wonderful space. I think there are so many good people like Duffie, Thomas Croft, Liz Rice, and a bunch of other folks in the Cilium community. I think that's a wonderful project and moving forward. And if you still don't know what Cilium is, here is the logo. You can check the logo and start learning about Cilium as well. So
yeah, and definitely check Cilium.io, because that's how you can, come and do an install fest, learn how to install it, learn how to configure it, learn what it does, kind of more in a hands-on way. You can also come to an AMA and ask us anything. So if there are any questions that didn't get answered here, you can absolutely come and join us and ask those questions yourself.
Yes, absolutely. And if you're watching this session from the YouTube, all the links are available on the YouTube chat to grab and start your day one of learning Cilium with Duffie Cooley on the Echo, eBPF and Cilium officer. So we talk about technology, Kubernetes, all things around. So one question, let's say, I don't know, you are a sports passionate person, or what's your favorite sports part? Then I ask another question. What are your favorite sports?
I would say, so I'm a motorcycle rider. I definitely enjoy riding motorcycles. I haven't really done any track days or anything, but just getting out there and doing motorcycle rides is one of my favorite things. As far as like other sports, I would say I do enjoy, in America we call it soccer, but everywhere else in the world they call it football. I do enjoy that. I also like hockey. Hockey is another great one. We have a great team here in San Jose, just south of me here in California. The Sharks, which are amazing. I love going to a hockey game and watching all of that craziness. Yeah.
Wow, wonderful. That's a great. So that you know a lot about sport. So I can ask the question you then. So what do you think if I ask you to compare Kubernetes with the support? What sports it's be? Like Kubernetes, you swap. Which sports represent Kubernetes?
Wow, that's an interesting question. What sport represents Kubernetes? It's an interesting one. I would think. So I guess I'll frame this one as like the Kubernetes project itself, right? So like the actual software components of Kubernetes. So Kubernetes is interesting because like there's a lot of autonomy at a lot of different layers.
Yes.
Right. Each individual piece is responsible for its own chunk of the work. And then we have like effectively, distributed systems models that allow us to allow all of those pieces to work together as a team, right, as a unit. But there are a lot of things that are responsible for their own bits. And so I think maybe I would probably go with maybe something like baseball, because in baseball there are so many individual roles inside of baseball, but together they form a team, right? Like those people that are out there doing the thing, like they're like, yeah, I would say baseball is probably a good analogy. And the reason I say that is because like you have like, you have their pitcher, you have your batter, you have your catcher, you have like the different basemen, you have outfielders and infielders, and like you have a lot of different unique roles that have a lot of autonomy. They're responsible for doing their part very well, right? But together they have to like, work towards some common goal to be able to really win as a team.
Yes, absolutely. The baseball from the Duffie Cooley answer, and the same topic. On which sports how you compare Cilium to that sport?
How do I compare Cilium to that sport? So Cilium, I think to some degree, is like the connective tissue between all of those things.
Yes.
I don't know exactly what that would look like from the baseball perspective, except for just basically that kind of that incredible focus that the entire team brings to it at the same time. Like, like in baseball, there's nobody like looking up at the stars or trying to understand what's happening, in the crowds or any of that stuff. Like in baseball, everyone who's out in the outfield is focused on one thing, and they communicate in a way, even without words, they're able to communicate very quickly. Everybody knows what the expectations of everyone else is, and they move together as a team very quickly. And I think that focus that they bring to it is probably maybe where the Cilium part would relate to it, because we're at such a low level. It's like that. Cilium is the connective tissue between everything. It allows us to make decisions about whether things are allowed or denied from a network policy perspective. It gives us a lot of relevant, rich metadata about network connections or process events. And that focus, I think, is really where it comes in.
Yes, absolutely. So I think about same with this baseball, but how the player think about for the game. We can thinking process is we can compare with the Cilium project as well. So great, wonderful. So last question: how you plan your day?
How do I plan my day? So usually I'm looking at my calendar a couple days out to try and understand like what my goals are. I have a number of projects that I'm working on, trying to move forward on a daily basis, and so I usually try to peel off some time in my schedule and put it in the calendar in that way, so that I can understand like here are my areas, here are my times of focus that I can move particular elements of my job forward. Whether that means working on a blog post, whether that means working on Cilium Enterprise as a certified operator inside of the OpenShift ecosystem, whether that means like a variety of different things. I can actually, peel off a couple hours and work on a variety of on any of those particular projects, and then the rest of it is, and then I set up some time to meet with and help and work with a lot of my coworkers and understand like what's happening, both from a feature perspective with the Cilium project, and maintain, kind of an understanding of where we're going with like eBPF and a lot of the different enterprise features that we're building, and then. I guess, the rest is like, catching what happens. I think, one of my favorite quotes is, life is what happens when you're making other plans, and so I definitely, expect a somewhat interrupt-driven day as I move forward. Right? Like even working remotely, there's a lot of stuff that just happens pretty quickly.
Yes, absolutely. So one question I forget, I just came in my mind. Well, which one of the person in the whole CNCF community is help you a lot during the Kubernetes, your time, your whole journey into the CNCF?
I can't think of one person.
But you can prepare a list out.
Yeah. Let's say it's a huge list. Yeah. Like it's a huge list. Gosh, pretty much, yeah, I mean, I would say that like all of the special interest groups are filled up with people that have helped me over time. Whether that means I've asked some question and received an answer to help. But yeah, like the special interest groups are absolutely like treasure troves of folks. The folks in SIG cluster lifecycle, the folks in SIG auth, the folks in SIG networking, the folks in all of these different special interest groups yeah, each of which have helped me, and I like to think that I have helped over time. Um, it's been incredible. I mean, like, enough can't be said of the amount of the body of work of like what Jordan Liggett has out there. Like that guy is amazing, like absolutely amazing. Tim Hawken, incredible. Joe Beta has been an incredible resource over time, not only in technology but also just in personal stuff. I think that Joe is an incredible individual. Chris Nova continues to be an incredible source and inspiration. My very good friend Ian Coldwater, and the rest of the Sig Honk crew, like Rory McCune and Brad Giesemann. I think we all level each other up all the time. I could go on. There's probably like a list of 30 people. I can't say for sure like any one person that has really driven me or helped me more than any other.
Yes, absolutely, absolutely, and that's why I like the CNCF collaborative CNCF community a lot, because there is not just one person we pinpoint. This is the person. We have a list of
Yeah,
50 and 100 people.
it's
We don't.
huge. Like
Yes, absolutely. So thank you very much, Jeffy. It's been a wonderful talking with you today, and I learned a lot during your live stream on the Eco and TJKI8s. Every time I hop into your channel, I learn new stuff. Every time I see their tweet, I learn so many new stuff. So it's been a wonderful talking to you. You make my time special today, and hope to catch up you again again in the future as well. But today is a special feeling I can't describe in word. So I finally met you, fulfill my dreams today. So everyone watching this session, follow Duffie on the Twitter. He's been a wonderful person to get involved with. Nice human being, always welcoming, and also give you some problems. Share the wonderful things happening around the eBPF, Cilium. So all the links are available. Follow Duffie, go to the Echo, and start learning eBPF from today. So Duffie, just 3 or 4 words, explain eBPF and Cilium. Just 3 or 4
yeah,
words.
yeah, I would say there we go. Oh, it's backwards. I was going to say my Twitter handle is MAUILION. So if you want to follow me, that's how you can do it.
Yes, absolutely,
No,
absolutely.
yeah.
Yes,
Anyway,
absolutely.
so eBPF and Cilium in a few words. I'd say that I think we're changing the with eBPF, since we're operating at the kernel layer and we're able to make like so many decisions kind of at that connection layer. eBPF gives you the ability to expose a couple of different things. It gives you the ability to manipulate network information at that kernel layer, and so we can do things like accelerate the connections back and forth between pods on the same host or between different hosts. We can do smart, intelligent routing and all of that stuff because we're just kind of operating right at that layer. And one of the other big values of eBPF is context, metadata, information about like what's actually happening at that network layer. But we can also do a lot with what's happening at the process layer. So eBPF can actually give you like a process tree ancestry. We can understand what system calls a given process is making. And we can actually build and improve on things like, seccomp profiles. We can actually define the ability to ensure that whenever a given process tries to make a particular syscall or access files at a particular path, we can actually kill that process. We have a lot of great capability to model a different security model, or to define a different security model, both at the network layer and at the process layer with eBPF. What we're doing with Cilium is exactly that. Right? We're leveraging a lot of that same capability in eBPF and bringing it in and bringing it to a user experience with Cilium, right? And I think that is kind of the definition of what we're trying to change here. We're trying to basically improve networking, security, and observability for distributed systems today. Whether that means leveraging, that means leveraging BPF and eBPF and extending eBPF both at the kernel layer and also within the product to be able to be able to drive that capability forward.
Yes, absolutely, absolutely. Thank you very much, Jeffy, to be on the call with me. So my 3 words for the Cilium are hiding the complexity from you and
Yeah,
making the networking simple. As simple
exactly.
as easy it is. So thank you, Duffy.
More
Wonderful
important.
talking to you today. And
Yep.
everyone who watching this session today, tell us about if you want to share some another thoughts around what we want to cover again in the future podcast. So I will be continuously monitoring the chat and what do you think about what is happening in the eBPF in the next year. So thank you very much for tuning into the cloudnative.fm podcast. Hope to join you again in another guest in another episode. Bye bye everyone. Stay safe and stay healthy.
Thank you, everyone.
Like I said, there's that K3s API server inside there. There's not a scheduler in the virtual cluster. So, so the way that works is the scheduler on the host cluster, you know, the one that the Vcluster is running inside of, that's the one that's used to schedule like pods. And the way that works is there's a syncer process that basically, you know, when a new pod's, you know, when you go to start up a new pod inside the virtual cluster, it, you know, syncs that information to the host cluster, and then that scheduler picks it up and runs it. And so there's